Hi people, I'm Mrs. Gerber and we are busy now with part 2 with the ABC of organic chemistry. Now, if you can recall, in part 1, I said that my grade 12s not only got 100%, but they also did the best in Tshwane South. They had the highest average. Now, that was with technical science. Plus minus 2016, I'm not 100% sure if it was 14 or 16, 15, round about there, the department started with technical science. So they got their highest average in Tshwane South in technical science. Now in grade 12, the technical science and the physical science theory was exactly the same. The difference being in technical science, they didn't get level 4 questions, and they had a larger part of practical that counted more in technical science, but the contents, the theory was exactly the same. I'm making these parts for that learner or those learners that miss something. Their circumstances were not favorite or in their favor, and they could not attend classes or whatever the reason may be, because these 5 parts that I'm going to do, eventually going to do, is actually a good summary of the 9 functional groups. And I'm doing that for those learners that had a problem specifically in some or other part of the organic chemistry. Now, let us look at haloalkanes. The haloalkanes, are also called halogenoalkanes or alkyl halides, are those alkanes where one or more hydrogen is replaced by a halogen substituent. Now, you know halogens is in group 7. So just for interesting, we also get monohaloalkanes where there's only one halogen. And then obviously also the primary, secondary, and tertiary haloalkanes that we look at in part 5, where you have one carbon atom attached to halogen at the primary. You've got 2 carbon atoms at the secondary halogen, and then you've got 3 carbon atoms attached to the halogens in the tertiary haloalkanes. Now, the halogens being in group 7, as we said, fluorine, chlorine, bromine, and iodine, becomes then the prefix of fluorine becomes fluoro, the chlorine becomes chloro, bromine becomes bromo, and iodine becomes iodo. So you have your prefix of your halogen, you've got your root word, the number of carbon atoms, and then you've got your suffix, the alkyne or whatever functional group is then added to that specific compound. So here's just a very simple diagram indicating the X that can be replaced by fluorine that becomes fluoro, chlorine that becomes chloro, bromine that becomes bromo, and iodine that becomes iodo. Now, when we have then one carbon atom, it is meth. Functional group is an alkyne single bond, so it's ane, and then the prefix being chloro. So it's chloromethane, common name being methyl chloride is your general formula, then CnH2n plus 1, and the X being the halogen. So again, we note the prefix is then the halogen, the root word being the carbon atoms, and then you get your suffix being your alkyne or your functional group that is added. Example, 2 carbons. So it is then F, ane being the functional group, and chloro, chloroethane. 3 carbons, chloropropane. And again, I added here just the one in brackets, indicating that when it's at the first carbon, you do not need to put the number 1 there, like we didn't put the number 1 here at chloroethane. You do not need to put the 1 when it's just at the first carbon. You can put the 1, but it's not needed to put the 1 there. Right, if you look at bromine, Then bromine, the prefix is bromo, being 2 carbons, it's eth, single group ane, bromoethane. So the common name here then being ethyl bromide. And again, I just wrote down the general formula so that you can see the molecular formula is then C2H5Br for bromine, the bromoethane. Right. Now, you must also note that when there's more than one halogen, the prefix then will be 2 for di, 3 for tri, and 4 for tetra. So I've used an example here where we've got 3 chlorines. So the IUPAC name will then be trichloro, meth for 1 carbon, ane. So it's trichloromethane. The general name then here being chloroform. So where there's 2 carbons, you have to then number the carbons to indicate that a halogen is at the first carbon, here being 2 halogens, bromines, that is then dibromo, but it's at carbon 1, the first, the one bromine, also at carbon 1, the second bromine. So it's 1, 1, indicating it in the prefix. So it's 1, 1, dibromo, eth for 2 carbons, ane, the functional group. So it's 1, 1, dibromoethane. Right. Here we've got an example where the functional group is an alkene. You have to number your carbons. Functional group is then at the first carbon. Remember, we said that at the suffix, the number of the carbon atom is written just before your suffix. So it is here 3, iodine is at carbon number 3. So you have to indicate it in your prefix, the location of the halogen. So it's 3 iodo, iodine becoming iodo, prop for your 3 carbons. At the first carbon 1 in. So it's 3 iodo prop 1 in. Common name being an alkyl iodide. Here again, you number your carbon atoms. Fluorine is at the second carbon. So if you started at number 1 on the left side, or you started at number 1 on the right side, fluorine would have stayed at carbon number 2. So it's 2 fluoro, prop being 3 carbons, ane, 2 fluoropropane. Common name then being isopropyl fluoride. Right, now we get to the alcohols. Now the alcohols, I just want to, I'm just recalling now something quickly. If you look at I just want to say something about the haloalkanes. If you look at your haloalkanes, let me show an example here. Where you've got 2 carbons, you've got 5 hydrogens. Here you've got 3 carbons and you've got 7 hydrogens. I just want to say that specifically, that also there's a difference following the carbons from the first to the second to the third to the fourth and so on. There would be a difference of 2 hydrogens. So you'll see that the haloalkanes are also part of a homologous series, right? I just don't want to miss that. Tell you that they're also part of they also form a homologous series. Right, now we look at the alcohols. Now an alcohol is an organic compound where there is a hydroxyl functional group. So you get hydroxide added to a carbon atom, minus OH. So the most commonly used alcohols is the methanol or ethanol, the suffix then being -ol. So the specific alkanes last letter is then being an E is replaced by -ol. Right, so let's look at this example. 1 carbon, that is methane, being a single bond here, being an alkyne, but the E is then replaced by the -ol. So the IUPAC name here will be methanol. The general formula then CnH2n plus 1 OH. Molecular formula being CH3 OH. So you see 1 carbon, 3 hydrogens, and OH. Going to another extra carbon being 2 carbons is then ethane, E replaced by all. So the IUPAC name will then be ethanol. Right, so you can also see here molecular formula. Next carbon from 1 to 2 carbons, it's 5 hydrogens. Right, so there's a difference of 2 hydrogens, OH. So this is also part of a homologous series, also forms a homologous series. Now here we've got 3 carbons. Number your carbons. Your OH is at the second carbon. So it's propan 2O. That's your IUPAC name. Here we've got 4 carbons. So your OH is at the first and the second carbon. So it's but being 4 carbons, and your location is at the first carbon and at the second carbon, and being 2 OHs here, or 2 hydroxides, it is diol. So it's butan 1, 2 diol. Right, now we've got 5 carbons. Yeah, we've got 6 carbons. So at 5 carbons, you number the carbons. The OH is at the third carbon, right? So it's then pentan, pentane, 3-ol. That's your IUPAC name. And with all of these people, you can also apply your functional groups, your general formulae, and you'll see it comes down to when you do your molecular formulas, you'll see that it also forms part of a homologous series. So here you've got 6 carbons, and specifically the hydroxide groups are at the second, third, and 4th carbon. So it's 2, 3, 4, triol. All right, triol. So I believe that you now have a clear understanding of the functional groups. We did the alkanes, we did the alkenes, alkynes. Now in part 2, we did the haloalkanes and the alcohols. In part 3, coming now shortly, I discussed the aldehydes and the ketones. And then part 4 is the carboxylic acids and the esters. And in part 5, we'll do lots of examples and then add the branch groups so that we can look at some of the exam papers and some of the questions that's asked there. Thank you, people, and I look forward to see you in part 3 and 4 and 5. And I really do hope that these parts will help you understand where you've missed something, and we've missed something, and if you can revise. And these parts will also be available in CDs. I'll have them available in CDs and give you later on the information where you can order them. And I'll also go to the schools where I will promote these parts. Thank you very much.